anyone traveling to Florida, if your travel plans have changed because of the storm, please contact Amy at 267-403-0999 and plan to meet after the closing ceremony. We'll make an announcement again once we're done.
We hope you guys have had a great time this weekend, learned a lot, hopefully met some new people you keep in touch with. This is really a great place to build community and get to know people. We have a long list of people we want to thank, so please stick with us. We'll start off with our amazing sponsors and partners of PennApps for their continued support. Without them, PennApps wouldn't be possible.
These companies help pay for travel, your food, t-shirts, prizes, and so much more. They provide hardware for you to hack on. They also provide mentors to help you out. So let's say thank you to the following people. First off, our partners, Penn Engineering, obviously, Architects, and Weiss Labs.
Then for our sponsors, we have a long list. We have BlackRock, Google, Facebook, Vonage, Palantir, Squarespace, Capital One, Oscar Insurance, Stevens Capital Management, Two Sigma, A16Z, Goldman Sachs, Hudson River Trading, Qualtrics, Jane Street, Lutron, Soylent, 1517, Airbnb, CBRE, Center for Healthcare and Innovation, Hasura, Giphy, M&T, Penn Wharton and Entrepreneurship, Bloomberg, Penn Nursing Science, Wharton Customer Analytics Initiative. It's a long list, but please give a round of applause. These are incredibly important people.
Now, as you might have seen, the people running around all weekend, we've been working on this for over a year now to put this great event together. Can we have the organizers and the audience stand up? Any organizers here? We got 1, 2. All right, let's hear for them. Any mentors in the audience? Mentors? Sponsors? No? Well, they were great help, obviously, as you might have imagined over the weekend, and all the volunteers as well. Special shout-outs to Killian Feeney, Amy Reese, Joe Davis, Ira Winston, Shambrel Jones, Joe, Mark West, Kim Marker, Chris Warhus, and Chris Rogers, Penn Engineering, and the housekeeping and the faculty staff.
So now our first round judges have helped us in narrowing down the crowd from the tons of submissions we had to just 10 demos we're going to do here for you. Those first round judges were drawn from local Philly friends of PennApps, sponsors, Penn alum, and a bunch of people who are really interested in the hacking community. Now we're going to give you some of our final round judges. We've given them the difficult job of narrowing these 10 great prizes down to just 10 great hacks down to just 3. The judges are starting at the top. David Monerat, he's the director of intellectual property at Comcast, started as a legal specialist in the Army, and then moved to an application developer, consultant, and finally joined Comcast in 2001.
Our next judge, you might have already heard from him at the opening ceremony, Charlie Cheever. He started working at companies, worked at companies like Amazon and Facebook. He later co-founded Quora, the popular question and answer platform. And fast forward a few years, Charlie is now the founder of Exporter.io. That makes the creation of mobile software a lot easier.
Our third judge is Craig Frieden, a senior technology manager at SIG. He graduated from the University of Pennsylvania and is judged for the first LEGO League Robotics, PennApps in the fall, as well as the Wharton Business Plan competition.
And our fourth and final judge is Keshav, who's a co-founder of Compose Labs, Inc., a web consumer company. And before that, he co-founded Eager Panda, which raised $3 million in venture funding. He's also a medalist at the prestigious International Olympiad in Informatics.
So in order to narrow down these hacks, the judges are going to judge by basically 4 criteria. The first of which is originality. Is the hack just another generic mobile, local app, social app, or does it do something entirely new? Is it trying to take a new approach to an old problem, kind of that innovation standpoint? Another aspect is going to be the technical difficulty. Is it an interesting app? Is it require some intense thought and coding, or is it just a wrapper on a couple APIs?
You'll also be judging polish of the app. Is the hack usable in its current state? Is the user experience smooth? Does everything appear to work? Is it well designed? And last but not the least, and I think the most important one, is usefulness, which is the hack practical? Is it something that people would actually use?
Yeah, so without further ado, we're going to move on to our final demos. Each of these top 10 teams will demo for 3 minutes, then have a brief Q&A from the judges. Now is a good time to go check out our YouTube link, send it to your friends, let everyone know about this. We're going to go through the demos.
All right, first up, we have Move It, and on deck is Angstrom's Matter.
Hello, PennApps. We are Move It, and we're going to show you some cool stuff today. Let's just get all set up. while they're getting set up, let me just tell you how we came up with the name. Now, how many of you guys have seen Madagascar? Yeah, now you know what I'm talking about.
Okay, so basically what we're going to do is we're going to interact with reality by picking up these objects and moving them around. So right now, he's closed his fist and he's picked up the object and he can move it around. And when he opens up his hand, it'll be placed right there. So the way we do this is using the connect right here, which gives us a bunch of data about our joints. And basically we use the joints from the wrist and the fingertips to determine whether your hand is open or closed. And from that we can run a Python script that tells us about which objects are in the area. So if you want to talk about the Python script.
Right, so as you can see right here, when Hardik, he grasps something, so he just needs to put his palm in front of the object. At that point, we have a Python script that generates or like looks at a 300 by 300 frame around the center of his palm for the object, for any objects in the area. So how we do that is we use some edge detection technology. If you guys have heard, there's canny edge detection method. So we basically go point by point and check for any gradients in the RGB values for any adjacent pixels, and that can give you the edges. Do you want to talk about what you did?
Yeah, sure. So a lot of you are probably wondering what are the applications of this software. What we see it useful for is that, well, I mean, who wants to move all their furniture around and then like remove it again and again and again if they don't know how it's going to look? That's obviously one of the applications. It makes our lives a lot easier. Another one, obviously, is that in a lot of places, it's very expensive to remodel them and then decide later that you want something else. So that saves a lot of hassle and a lot of money there too.
In addition to that, Lockheed is working on some augmented reality glasses. So, for example, if I'm a sailor and I'm pretty young, I don't really know I don't have any technical specialties, and let's say I need to make a repair on the ship because these things happen once in a while. I could literally just put on some glasses, and someone remotely could. Someone who specialized in the repairs could remotely talk to me and literally move around objects on my screen, and I can see it move around and give me step-by-step instructions on how to fix the repair.
To sum it up with the limited time that we have, it's really it's a question of closing the barrier between the real world and the virtual world and seeing how we can interact with it in more ways. This is just one way we hope we can contribute to that journey, and hopefully we can see that in the coming years when the virtual world is something we use more and more often, can help with that. Thank you.
Do we have any questions from the judges on those? Between rounds, you guys can ask a couple Q&A if you have anything interesting to ask, anything you're wondering about.
One quick question. Where would you say you spent most of your effort, or what maybe another way to ask the same question is, what was most challenging? So some of the work is going to be done for you by the APIs and toolkits that you use, and then some of the work you have to actually spend time doing your own coding. How would you describe how you spent your time?
So Hardik and Ria right here, they worked on the connecting stuff together with all the APIs. For the hardest challenge we faced as a team, however, was the edge detection software, because originally when we were just looking at objects, if we run an edge detection on the whole image, things can get very large very quickly. Things get slowed down. So we had to limit it to just 300 by 300 pixels around where you close your hand. So that automatically sped it up, and then just from there, finding the best algorithm, because there's a lot of stuff online to explaining how to detect objects, but not all of them are the best. We had to run through 2-3 different methods before we can find something that actually worked. Does that answer your question? Sorry. Cool. Any other questions?
All right, thank you, Move It. Next up, we have Engstrom's Matter, and we have Shelf on deck. All right, you guys can get started.
Hello, my name is Max Baris, and along with Chris Fredrickson, we developed a scanning tunneling microscope, a device capable of taking pictures of atoms. With the picture shown here on the left was taken with our device. This is an image of highly oriented graphite, which on its surface is a 2D layer of carbon atoms arranged in a hexagonal arrangement. And in this image, you can see the hexagons that our device was able to image. At the corners of this hexagon are individual carbon atoms. On the right is shown an image from a research paper. This was typically captured with a $30,000 to $40,000 piece of equipment, but we were able to capture the same thing with what we developed at PennApps.
And so the way this works is we start with a tip that you might be able to see in there that on the end comes to a single atom. That's attached to a piezo element that's been split into 4 different quadrants so that we can control the expansion and contraction of each quadrant. That allows us to position the tip in the X, Y, and Z axes with about tens of picometer resolution, less than the width of an atom. This is brought close to the surface by a bunch of adjustment knobs and also the Z-axis of the piezo element. We use the piezo element to scan the surface of the sample, and we look at and because we've brought the tip so close to the sample, quantum effects quantum effects are added in, and you get a tunneling current from the quantum mechanical effects there. And so as you're scanning over the surface, depending on where you are over the sample, whether or not you're right over the carbon atom or not, you get a different amount of current. And that's fed through a very high gain transimpedance amp and to the Arduino Uno with the analog to digital converter.
On the Arduino Uno, the X position, Y position, and current intensity from the previous step are used to plot the electron micrograph in real time. When, for this example, as we lower the probe into the sample, the tunneling current increases, which increases the intensity of the image. This allows us to produce images like this. And that's it. Thank you for listening.
Thank you so much, Engstrom's Matter. Judges, do we have any questions?
Could you describe sort of how you came up with this idea, what kind of background you had to I would never think about anything even close to this during the duration of a hackathon. So where does the idea come from? How you got into it?
So this is originally Chris's idea, so I'll defer to Chris.
Yeah, so essentially I saw this online a couple years back, and I just thought it was really cool. There's a handful of people that have made these DIY. You might see one every 3 or so years that posts something about it online. And I have just always wanted to make it, and I finally managed to convince Max to jump along and help.
So much fun.
Good stuff.
Any other questions?
So you mentioned that you saw some other people do this. So did you take a different approach to it, or were you just recreating?
Yeah, so we ended up using many of the principles from those, but with the time, no one's ever done it within this time constraint. So no one's ever done it even with acrylic as the substrates. So there are many different, because this is very high precision, you care about thermal expansion of materials. So it took quite a lot of doing to get it to work with the materials we had at hand. But we used the general concepts from the ones that we found online.
Sweet. Right. Thank you so much, Engstrom's Matter. Let's hear it for them. Next up, we have Shelf, and on deck is Todd.
Hi everyone, my name is Zachary. Behind me are Matt, Ellis, and Lucas. And we have something really cool to show you today. We call it Shelf, and it's a smart pantry system that is designed to work well with existing fixtures in your house and elsewhere. To begin, I'll let Matt introduce us.
Okay, so this is the shelf device itself. I'm actually going to, so how it works is this is mounted on the back of a pantry door and scans what's inside of your pantry. So normally this would, in a full consumer application, be triggered every time you close the door of the pantry. We don't have a pantry door to close, so I'm going to trigger this manually. So right now this is going to actually scan across each shelf of this two-shelf pantry that we have here. Once it's done with one shelf, it'll drop down to the second shelf, as you can see there. We'll show a better view of just this piece later, and take a bunch of images from each of those two rows. And once that's done, we hand it off to our server to pass it on to the Google Visual API.
So can we have the computer stream here? So the images will come onto the stream a little bit later, but what we basically have here are the images that we get directly from the camera. What we do is pass this through Google's Visual Vision API, and we use detection for logos, labels, and web entities. And since each of them individually is somewhat unreliable, we combine these all as well as our own data set of potential products that we can have in a pantry in order to make a guess of what the pantry includes. And so we're going to run it one more time, but this time we're going to have Zach take away some of the Cokes, and we'll see if it can detect that they're gone. In the meantime, Ellis will talk about the client app.
Sure. So this would be pretty useful on its own, but it's even more useful when you combine it with the companion app. Now, the companion app is, it allows you to scan a QR code to sync with the device, and then afterwards, you no longer need access to the device, and you can simply view your items to buy and other items all on your app. So if we show here, we've got an Expo app, and here we see that items to buy, Coca-Cola, other items, Doritos, Goldfish, Planters. And so this way we can just open the app and we can see exactly what we want. So you no longer have to call home and ask what's left in the pantry. You can simply open an app and find out.
Now, if we could get the camera to point back over here.
Camera 3.
Camera 3, please.
No, wrong one.
No. Maybe? Okay, well, we want to show you exactly what the project does.
So it's an Android Things device that's powering this. It has two servos, one to control the rotation of the camera and the other to move up and down vertically using a winch. And I think we're out of time. So do you have any questions?
Oh, yeah, so you guys can ask any questions you want. Yeah.
So what was the most challenging part of putting this project together?
Well, as much fun as it was working with the Android Things, it's still very new and it presented a lot of challenges, especially, for instance, working with the camera. We faced a lot of difficulty with finicky connections and just somewhat unusual APIs. But all in all, it was a surprisingly smooth project, especially given the complexity of it and the fact that it's made out of cardboard.
All right, thank you guys. That was Shelf. And now we have Todd. Up next is The Lord of the Rings. You guys are good to go.
Cool. Right. So this is Todd, the multi-dimensional robot. Can we get the
yeah.
Yeah. So what we decided to do for this robot is, so we had two people that were interested in robotics and one person that's interested in game design, and we decided to combine the two. Now we had seen people control a game with Arduino before, but we didn't want to make just a game controller, something in the real world. So currently, The battery on Todd is kind of dead. So we might have to keep this plugged in. We're going to try to get it to... Oh,
there you
perfect.
go.
So this is the game interface.
So it's kind of, I'm not sure, it's shifted a bit, but in any case, the concept of the game is that it's basically two players. One is looking at the screen, has no controls whatsoever, and there's that robot that we control with this Bluetooth, with this Arduino connected to our serial port here, that communicates with that specific Arduino with the Bluetooth. So can you move the robot? There you go. So when that moves, the actual robot on the screen moves in the exact same direction, and it's one-to-one with an error of about 3%. Can you rotate about 90 degrees to the right? There you go. So it's very, very precise. And so the point of the game is that he shouldn't be looking at the screen. Instead, he should be looking at the robot as a point of reference. So if I tell you to go straight forward, to collect that specific screw, keep going, keep going. Don't stop, just keep going.
Keep going.
All right, so now if we hit this wall, our robot actually stops. And now we're currently pushing forward, and it basically sends an information to this Arduino that sends it back to the other Arduino, tells it you can't move anymore.
So to be clear, I'm trying to go forward, but right now, basically those obstacles are invisible obstacles in the real world.
And we just can't move anymore. So right now we just move backwards. All right, so let's try to do a 180 to the right. All right. Let's do 30 degrees to the left. That's fine. All right. Keep moving forward until you hit the red spot. So if you see, guys, these red spots are basically death zones. If you hit them, your robot explodes. So go a bit to the right. Yeah, there you go. Keep going forward. And then just...
So...
Oh, man.
One of the harder parts... one of the harder parts with this was... if we first started with constantly pulling the Arduino over and over, as in the controller, to get what direction to move the robot. But that turned out to make the frame rate really, really, really slow because we're constantly using all our time to pull the controller. So we sort of had to switch it to like a more interrupt-based system where the controller says forward, and then we have to wait for the stop command in order to stop. And then Unity will interrupt the Arduino with an X if it can't move. And then it'll switch communication between Unity and the Arduino with reference to like, this is controlling this directly. It's not asking, okay, can we move forward? And then if so, move this. It's always...
In any case, the basic idea that started this whole concept of just making a cooperative game is to just have a serial port that connects Unity to Arduino. Yep, and that's it.
Thank you so much. I'll answer questions. I'll answer questions if you have.
Thank you so much, Todd. Judges, do we have any questions for them?
So outside of gaming, can you think of any other applications for something like this?
I think in terms of like navigating corridors, we could have someone remotely controlling, we can have someone controlling, or at least in robotics applications where you have like the concept of like invisible walls or boundaries you can't cross, you can use this sort of interface to create boundaries, maybe not through a game per se, but like we saw one of the hacks that had like paper mazes, and that would, we could possibly draw something like a maze and then have it be created as a boundary so robots wouldn't go through certain paths.
Okay. All right. Thank you so much, Todd. Next up, we have Lord of the Rings.
Hello, everybody. We are 3 high schoolers from New Jersey. I'm Steven, this is Rishi, and behind me is Justin.
All right, so imagine a scenario where you're trying to talk to someone who has a speech impediment. Because of mental disability or deafness, they are not able to express their ideas effectively to you. American Sign Language is a solution to this problem. However, not many people know it, and it is difficult to learn.
Enter the virtual keyboard. It gives people a chance to type everywhere and every way. It features several accelerometers which communicate with Arduinos to give effective communication. We wanted to target people who had mental disabilities to give them a chance to communicate effectively by typing instead of talking.
As the weekend went on, we saw that this has much more uses than simply communicating. The things that people who are mentally disabled have to say. For example, in virtual reality, the current method of using a keyboard, you actually have to frequently pluck letters out of an application, which is like very slow and ineffective. However, using a keyboard glove will make the experience of using a keyboard in a virtual reality application much more immersive and fluent with what you are doing.
You could also use it in an IoT home. Imagine you're sitting on a couch and you want to turn on the lights. Just typing in lights on your virtual keyboard glove will turn on the lights. But let's say you just want to use it as a normal keyboard. So as you can see, my hand in the camera, you can see that I have accelerometers on my fingers. As I press down, the data analysis portion will start, and it will get the X, Y, and Z tilt of my fingers. Based on the tilt, it can tell if I'm on the top, middle, or bottom row. So right now, as you can see, this accelerometer here will get the W, S, and X keys. Sorry. So as I press down, you'll see the keyboards going down, and the letters are appearing on the screen, depending on which key I'm pressing.
Yeah, explain more.
Yeah. So all these accelerometers will connect to different Arduinos, and you'll get every single column of the keyboard.
Okay, so the really cool thing about this is, like Rishi said, we could use this basically anywhere, a couch, literally anywhere. You don't need a surface to type on like he's currently doing. You could type in midair. This is made possible because we are using relative X, Y, and Z tilt analysis as opposed to simple X, Y, and Z absolute positioning. So I could take my hand and move it up here, and it won't actually sense that as a keyboard signal. However, once I start typing over here, it will sense that.
This is the future of typing. Thank you, and do you have any questions?
How fast and how accurately can you type on it?
It's actually pretty amazing. This $2 accelerometer can get 1/100th of a degree in accuracy and 100 samples per second. So it's very fast and very accurate.
However, the fact that we're using Arduinos, which are like prototyping hardware, it's kind of laggy, but with the right type of hardware, we can make it much faster than it currently is.
Is there another hardware component that gathers all of the information from the different Arduinos? How many Arduino boards are you actually using?
So ideally, we would have 10 Arduino boards with 10 accelerometers for all of our fingers, and then we would use a Raspberry Pi to consolidate all that data and send it to the APIs online. So we had this working, but unfortunately, our Raspberry Pi short-circuited a couple hours ago.
All right, thank you guys. That was Lord of the Rings. And next up, we have Grep Job, followed by Enigma.
Hello. Hi, guys. We are Grep Jobs. My name is David Grossman. I'm from the University of Miami. And these are the 3 J's. We've got John, Jay, and Jacob, 2 from University of California, Riverside, and 1 from Texas A&M. We're a few randos that came together to try to make something great. We're Grep Jobs. As you Linux users know, Grep is great for searching files. Grep Jobs is going to try to change the way that you search for jobs. I'm going to hand it off to John.
I'm Jacob. So this is our main page. This is a web application. Our main page, so basically what we're doing is trying to get you guys jobs. And the way we do that is we first type in a job type and then the location. So when we search for this, we're going to show 2 nice GIFs of your search, basically. And then we're going to generate this massive, massive map. This map is basically generating everything related to that job that you searched for and the job applications around. So if you see he's working around here, this is San Francisco, and you see this is a really big population for web development. Web development was the job that he searched up. You can move around the map, and there's different jobs, and each height is basically the frequency of the jobs in that area.
Yeah, sure. So, like, when it comes to the purpose of this, normally when you're like looking for jobs on LinkedIn or Indeed, you're looking at compensation and you're looking at location. The goal of Grep Jobs is to basically put together a bunch of factors and then make it very easy for you to like actually visualize where you would want to work.
For each of these jobs, though, we're actually web scraping off of LinkedIn or Indeed.com and inputting them ourselves. So we have around 1,500 to 15,000 actual jobs here. And you see he's scrolling down this list of each job that we've scraped, and you actually can click that apply button to get to that job website. And then, yeah, so this is basically a great way to get a bunch of data together and centralize it for job applicants like you guys.
So if you're interested in the stack, the front end is written in Vue and React. React is for the map. The map is written, it's programmed in WebGL, and we're using a React wrapper for it. The rest of the UI is written in Vue. And here for the backend?
Yeah, so the backend is written on Hasura, actually, on one of their microservices, and we're using another one of their microservices for the database. It's in Flask and Python, sorry.
Cool. Thank you so much. We are always improving. Check us out next week. It's going to be even better. And we're accepting applications for interns, so bring them up. We'll post them on our site, too. Thank you.
So how does one exactly apply? Because count me in. I want to intern this place. It sounds great. Judges, do you have any questions?
So tell me again how this is, like, why would I use this instead of going straight to LinkedIn or something else?
So this is a visual way to see where you can potentially work. So choosing a new career is a big epic. So something you have to worry about is where you're moving to, not only how much it pays and what company it's at, but where it is and what's the statistics on the company. Has the company been growing for the past couple of financial years, or is it in a decline? These are more additional factors that are easily visible through like a graphical representation rather through just through a plain list view.
So he actually wasn't showing up there, but on the right side with that giant bar, there was actually like, if you really wanted, you can find the average temperature of where that area is, and then also the as he said, the status of that company, if it's growing, if it's shrinking, and if it's like volatile or something like that.
And sort of a related question. So, did you come up with the intelligence in between sort of the visualization and like so you scrape and then you visualize and then that middle piece, is that something you came up with, or are you just plotting data that you got?
So we actually scraped all the data ourselves, and then we went through Google's API to get an actual location of like longitude and latitude, and then mapped it there onto the map. And each cylinder you see there is like a 15-mile radius of all the jobs that are in that 15 miles, basically.
And then on top of that, moving forward, it would be really cool to add like a bunch of layers. Like you can input layers depending on your personal preferences. This is like really a framework so that you can add like more personalization moving forward.
What toolkit actually drew the columns for you? Was that something you had to program yourself, or was that part of one of the toolkits you used?
That's a primitive in the React wrapper for WebGL. So all this is, it's WebGL on top of 3JS on top of the React wrapper.
Thank you.
All right, thank you so much, guys. Next up, we have Enigma, and on deck is Inventec.
Hi guys, my name is Jason, and over there is John, who's going to be operating the computer. So for our hack, we wanted to work on fixing the problem of political polarization. Obviously, this is a big problem, so we're kind of starting small. But one of the problems, right, is that a lot of the news you read is really biased. Because you're on Facebook, you're scrolling through your feed, your friends probably all have similar political opinions, they're posting pretty biased articles, you're clicking on them, and that's how you're getting your news. So we wanted to make it as easy as possible for people to see the other side of the political spectrum. So we did this by implementing a Chrome extension that'll automatically find the exact same thing, but on the other side of the spectrum. And when I say the other side of the spectrum, I mean equidistant from the center as you are at, but on the other side. So if you are reading a center-left article, it'll give you a center-right one. If you're reading a far-right one, it'll give you a far-left one. And the goal is really just to kind of see different sorts of articles. So right here, John is on Vox, which is right pretty far to the left. So he can just click on any article. This is completely live. So he's going to click on an article. It looks like he's going to click on this Trump Nancy Pelosi has an advantage because his cursor's over there. So he's going to click on that. And then if he just goes up to the Chrome extension, which is on the top of the screen, right? John, can you click on that?
Yeah, we're having some connectivity problems.
Internet. Oh, it is indeed loading, actually. We're trying to load a New York Times one too, but we'll see. PennAppsXVI. You can connect to my hotspot if you want. Might work. This is what's fun about live demos, is the Wi-Fi is often interesting. Connect to my hotspot. Cool. This is why I love Verizon Unlimited Data. Thank you very much. So now, if you just click that button right there, what it'll do is it'll automatically find a article that is, on this case, in the far right, that is talking about the exact same thing, and it'll pull it up side by side. So in this case, it looks like we got Breitbart, and then we got the Vox article originally. And you can just read them side by side and compare and contrast as you read them. And of course, this works across as many different news sites as you want. So you can do a New York Times. You'll probably get something from like the Wall Street Journal. And it all just kind of works. And the idea is it's as simple as possible. So that's basically it. So do we have any questions from the judges?
Could you give some more details on how do you figure out how similar two articles are based on content, and how do you figure out how dissimilar they are based on sentiment or
so basically, the first thing we did when we first started the project is we read an academic paper that was trying to quantify how biased different sources are. So it had about 100. We only chose the most popular just for the sake of the hackathon, so we have about 10 different sources in there that kind of range the spectrum. And we kind of put them into buckets. So we have, a group of like far left, a group of kind of like center left. Then we have like some more like medium, and then we just kind of group them like that. And then what we did is we took the title and we searched by title amongst kind of the group that's opposite from the current source. And within the title, that kind of gets us a baseline, and then we used a summary from the Google Cloud API, which has some NLP. And then we compared basically a bunch of keywords from the summary that Google created within a bunch of like about 10 different candidates to see which is the best match.
Cool, that's great.
Anything else? Fantastic. Thank you guys so much.
All right, thank you, Enigma. Next up, we have Inventec with Where W Lift. We have that typed wrong. Up next.
All right. Hey, guys. My name is Matt. This is Will, Cyrus, and Jeremy, and we're all sophomores from Carnegie Mellon. We're here today to show you Inventec. All right, so what is it? Well, we set out with this mission to be able to organize, small parts like LEDs, bolts, and nuts, and be able to do that completely autonomously and use some sort of internet-connected device. So we're going to jump right in with a live demo. If we could get the camera overhead and on the floor here, split screen. So the first thing we're going to do is Jeremy's going to open up the app, and he's going to scan the part he wants to input. In this case, it's going to be a red LED. So he's just going to take a picture of it, and he's going to click OK. And when he clicks OK, it sends it over to the Raspberry Pi, which is right here. On the Raspberry Pi, we run some OpenCV algorithms that we wrote to identify it. It identifies it as a red LED, and then he can place it into the input bin. The device, if you kind of watch in the front here, then lights up the second bin, which is the next available one, and it will actually drop it in there. You can't hear it, but I heard a little cling. Once it's in there, we're all set, and the device just returns back to its starting position. And now let's say Jeremy wants to get the nuts that he left in there yesterday. So what he's going to do is he's going to do a request on the app, and you'll see that it will actually turn red and eject the drawer. Jeremy could then take the nuts out, and then once he's done, he just leaves it there, and it uses neodymium magnets to pull it back into the device. Can we go back to the slideshow? Sorry. All right, so something really unique about this project is the like the breadth of technology that we hit on. So we went all the way from embedded systems and running stepper motors and servos and NeoPixels, all the way up to making our own server and our own app.
So I created an Expo app. It transfers the image to the Raspberry Pi over HTTP request. And I also made the Flask server on the Raspberry Pi, which serves as a database and also communicates with the Arduino.
So we used OpenCV for visual processing. We used the phone camera to capture the image, and then we sent it to the Raspberry Pi. In terms of algorithms, we first came up with like a color detection algorithm, followed by a shape detection algorithm, and I think by the end we were able to differentiate between resistors based on their color code. So here's a picture of the app scanning a 2200 ohm resistor, and then it basically shows this is recognized.
All right, and really quickly, the embedded stuff, we used an Arduino Mega, and we used that to control some stepper motors and some servos, and that's how we move all the stuff around.
All right, finally designed. We had over 60 parts in this fully assembled CAD model. Here's a picture of it. We CAD'ed it in 12 hours-ish, and we cut everything through laser cutting here at Penn. And
Thanks for the acrylic, by the way, PennApps.
Yeah, okay, we're done. Thank you.
All right, any questions?
We left some applications up there.
All right, yeah. Oh, that's gone. Never mind. There's no applications.
Okay.
You had pretty limited time to get this together. If you had more time, exactly what form would it take?
So I think the most immediate thing is we have 6 bins. That's not very useful, right? So we really have a vision for this to make it modular. So let's say, some warehouse buys a 100-bin unit, and then they can, stack 50 of those on top of each other. So we really want to just kind of scale this technology up, add more than one access to our, indexing system, and be able to support thousands of parts instead of just 6.
All right, thank you, Inventec.
Thanks, guys.
Thank you.
Only one question. Next up, we have Where We Lift.
All right, while we're waiting to fix that technical difficulty, we have Sorty McSortface coming on, and they're going to give you their demo first. All right, thank you, guys.
Awesome. You good? Hey, everybody. We are Sorty McSortface, and we're going to revolutionize recycling. Now, the reason why most people don't recycle is because it's too much work. You're about to throw something out, and you have to check if it has that little triangle on the bottom. You have to decide whether or not you put it in plastic or metal or whatever. It's way too much work. So just to be safe, you throw it in the trash. Well, we developed a smart trash can that does all of the work for you. We want you to be able to sort through it for you, and you'll be able to recycle. We want you to set it, forget it, and recycle it. My colleagues are going to show you how it works.
All right, awesome, thanks. So let's say Soylent. I like it shake, not stirred. That's just me. Now, I'm going to put it right here on the platform, okay? And once I put it on the platform, you'll notice that that action triggers our motion, has caused our camera to recognize the image. That image has been sent to our image recognition API, which we trained with our own models. And then it recognized what that material is made out of. In that case, the Soylent bottle was made out of plastic, and appropriately, the platform's tilted to go into the plastic box. So if I kind of open these up, right here, we can go back to the, yeah, awesome, thank you. So you see that there is 3 separate slots. So one for plastics and metals, where the Soylent bottle went, one for the food and non-recyclables, and one for paper. And so I'm going to do the same thing again, and this time I'm going to do it for a non-recyclable product. In this case, just some food right here. All right, so same thing again. It is going to be taking... There you go, see? So same thing, image recognition. In this case, it said EE, which means everything else. And this is an app we created with Expo.io with React Native, and that kind of tracks what exact products were recycled at this. So this has some nice data analytics to it.
Yeah, so taking you through the technology again, the best technology is one that's out of the way. And so really the point is, the point for most of technology is not to be in the way of people. And we've gotten sucked into this world where technology hinders us rather than helps us. So this helps us, it helps the planet. And really when we place the object on there, there's a camera that's on that board, a motion sensor detects, as is explained, the motion sensor detects that an object is in place. The camera is sent to Cloud API. Now we are currently using Clarify, sorry. Clarify, but we recently, earlier today, found a data set of 3,000 images for recyclable. Oh, sorry, we're off. And we'll just run it offline.
All right, thank you guys. Any questions?
What were some of the challenges you encountered along the way?
The fact that we're playing with cardboard as in other projects and the motors. Another big challenge is the training on only an initial set of 300 images, which was not sufficient for good accuracy. Now, we want thousands upon thousands of images. Only later in the game did we come up with the 3,000 images of recyclable materials that we've trained on Google's TensorFlow, which we hope to very near future switch Clarify out for Google Cloud Platform.
When was the first time this idea struck you? How did it happen?
So our first night here, I can just use this. Our first night here, we sat down, we brainstormed, we put like 12 or 14 ideas on a whiteboard, and then we just went down through them, eliminating them, and this was the last one there.
All right, thank you guys. That was Sorty McSortface, and now we have Where with Lift coming up. And next we have Pillar, or Pill AR.
All right. Hi, everyone. I'm John. I'm from Where with Lift and Go Cats. Yeah, it's like 3 people in the crowd. All right. So I took advantage of Lyft's API and paired it with Apple's AR kit to create an augmented reality app and view all of the drivers nearby you, as well as see your destination and eventually create a ride. So I'm going to start out with a demo, just to give you a perspective. So let's see who's out there in terms of drivers. Oh, we got quite a few up there. Let's see. Yeah, we got an SUV, can seat 6, 5 minutes away. Not too bad. Got quite a few right there. We got any in the crowd? Oh, yeah, there we go. We got a luxury car over there. Not bad. You know, I think we're going to take that one, guys. I'm a bit hungry. I think we'll go to Pat's. No complaints? Okay. Oh. All right, all right. Look, all right, you're going to have to forgive me for this one. All right, here we go. So let's see. Where are we going now? All right, it's over there. It's hiding a bit, but we got Pat's King of Steaks. Beautiful. So we're going to click the button at the bottom to get a ride. We pop over to Lyft, where we're able to call our driver, pay him, after which we can come back to the app and then watch him and his marker come near us in real time. So that's it for the demo. So one thing, the reason I created this app is because having used a lot of ride-sharing services in the past, one thing that I noticed is that there's a lot of difficulties when it comes to using a 2D map. One being you have no sense of depth. So let's say there's a car coming down the road and the app is telling you that, but you're in a busy city and it's behind 5 rows of cars and you simply can't see it. So this really helps with that in that you can see it, the bubble out in the distance, and you can find it like that. But I think this app really takes advantage of the technologies at hand, and I hope that that is apparent. So that is it. Thank you.
All right, thank you. Judges, do we have any questions?
What was the most challenging part of making this project?
All right, so I'd say the most challenging part was being able to look at the new scene kit and AR kit technology and being able to develop a coordinate plane in the scene, which would allow me to place the cars around and then view it and have a scale so that at a farther distance it would be smaller. Another challenge was definitely getting the Lyft API ready for iOS 11. It was actually not functional. I had to fix it a bit myself. So Lyft, if you guys need help updating your API, hit me up. No, it's not a jab. I'm asking for help. But does that answer your question?
Did you actually call a Lyft somewhere with this and watch it pull up and pick you up?
Yeah, it was pretty cool.
Cool.
All right, I think that's all we have. Thank you so much.
All right, thank you very much.
And our last hack for the evening, Pill AR.
Is this on? Okay, cool. Reset it. All right. Hope you guys have been enjoying the presentation so far, and I really hope you enjoy this one. So we are Pill AR. I'm Ryan. This is Yasmin, Avery, and Arlene. And to get into it, there are a lot of issues in the healthcare industry. One of them is that patients aren't very responsible with their medicine. Some of them underdose, some of them overdose, both unintentional and intentional. So we set out to try to solve that problem with our app. This is an app to help you figure out what pills you need to take and manage them, as Avery's displaying over here. The general use case of this is that you walk into your bathroom at night, open up your medicine chest or whatever you have, and you take all the pills out that you need to take, and you tap on them, and it'll pull up some information about the pills, mainly the dosage information. Like for Advil, you can only take 6 a day, otherwise bad things could happen, so it'll say you can only take 6. Avery, do you want to talk about ARKit?
So we use ARKit to display the information about the pills and how many you've taken that day so far. So if you look closely, right, we bring up a heads-up display kind of right above the pills, and you can see it says 1 pill taken so far, and there's a 6 limit, and you last took it 22 hours ago. So right now we're going to take a take an Advil and click on mark as taken, and you can see here Advil just appeared, and it's now on the list of medicines we just took. So we have a list of all the medicines you took in the past, and this could be extremely useful for things like if you start feeling bad one day, you can check to see whether maybe you forgot to take something in the morning, or maybe you took multiple pills that you've never taken a combination before, and the drugs just interacted with each other. So So we also figure out how many pills you're supposed to take for Advil, and I guess Yasmin's going to talk a little bit about that.
So we scraped a website called EMPR and got instructions of how to take different pills and decided what the maximum amount of pills would be from that information. And
I'll go over the flow of generally how this works behind the scenes. We can go back to the camera view. So it might be hard to see, but there's a little crosshair in the center of the screen. So you just point that at a pill bottle, and then we crop the image to mostly get just the logo. Then we pass this to the Google Vision API, where we get back a logo identification, or we use the web entities, which is kind of similar to OCR, image to text. So the logo is very accurate, so if we get a logo identification back, then we use that. If not, then sometimes you'll see things like Advil will be identified as ibuprofen, which we can then use to web scrape and get the same information as if we knew the actual brand. So we get the name of the drug from the Google Vision API, and then we web scrape for the dosage information.
So we're really excited to be improving the healthcare system, and a few other things we see doing in the future is, one, giving notifications in case someone either overdoses or forgets to take their medicine. Another thing is we could use APIs to cross-reference with other medicines to make sure that you're not taking two of them and you're not allergic to one of them, and that would really help with that. And
so those are some of our future plans. And are there any questions?
So the logo is a good starting point, but different pills have different kind of potencies and stuff. Have you thought about how to handle something like that?
Yeah, so do you want to answer this, or should I? I got it. So we tried to find that information from web scraping. It's pretty challenging from just obviously a logo name, because Advil can be sold in tons of different packaging. So the web scraping that we did actually came up with a lot of different listings of the size in milligrams and the number of and the amount of that milligram dosage that you could take. So we tried to do some math based on those dosages to figure out what we could do in the future.
And so for the image, we not only look for logos. After that, we do OCR to try to pick up any text on the bottle. So any text we cross-reference with our scraper. So if it comes up as a bottle, then we will search bottle in our scraper, and if it doesn't come up with any medical information, then, well, it comes up normally with a bunch of different words. So we search all of them and see if any of them come with medical information to try to read bottles and get any sort of medicine.
All right, thank you guys. Now let's hear it one more time for all of our amazing demos. You guys did a great job with your hacks, and these top 10 are the cream of the crop. Now the judges are going to go deliberate on who will be our top 3 winners. And while they're doing that, we're going to hear from our closing speaker, Alfred Berkeley.
So before working as a chairman of Princeton Capital Management, Alfred Berkeley was the president of the NASDAQ stock market. He was the vice chair for President Bush and Obama's National Infrastructure Advisory Council, and also served as a vice chair for the evaluation committee on the National Medal of Technology and Innovation. He's a proud Penn alum, and we are super excited to have him here with us today.
That's fine. I think that's work. Does that work? Good. I'm delighted to be here with you. It's really energizing to see so much inventiveness. I thought I would take you through 3 areas that I think people are unaware of or not paying as much attention to as they might. And then talk a little bit about a question I got. You may have seen me going around and introducing myself to some of you earlier in the day, and I got a very interesting question that I think I'll expand on a little bit. First I'd like to take you through 3 areas that I think are not well understood, that I believe are going to have powerful impacts on all the technology inventions going forward. A little bit of background. One day I was sitting in my office at NASDAQ, and I got a call. My secretary came in and said, "It's the chairman of the SEC's office." And being a regulated kind of guy, I said I'd be delighted to take that call. And it was a guy named Mike Halloran, who was the chief of staff for Christopher Cox, who was the chairman of the SEC. And Mike said, I understand you've got an experiment going on at NASDAQ about standardizing the language that's used on your website. And I said, yes, we do. We're working on a project that's an effort between PricewaterhouseCoopers, Microsoft, and NASDAQ to make it easier to move information between applications. It was a product language called Extensible Business Reporting Language. I'd like to see a show of hands if any of you have ever heard of XBRL, Extensible Business Reporting Language. Just a few. You're going to see more and more about it because, and other standardizations of language, because it's the next great opportunity for significant cost savings. I'm going to give you an example of the project that we worked on and how you can interact with it every day. And I'm going to talk a little bit about what the government's doing to expand the use of standard languages. You know, the ancient problem of the Tower of Babel, where we speak different languages all over the world, has been around since human beings began to talk. The financial languages that you see in the reports that companies provide on their progress has been all over the map, even just in English, different meanings for different words, different interpretations. One of the things that we did was to say we've got a lot of standardized interfaces at the operating system level, at the language, at the programming language level, at the presentation level, all the different pieces that have made this great substructure, this great infrastructure that you've used to develop these applications quickly. You're tapping into billions of dollars worth of development ahead, and yet getting information from one application to another has been very difficult. It started out as very difficult because the computer chips themselves were so small that people did all kinds of gymnastics with the language to try to fit a lot of information into a few places. It's the classic computer science many-to-one and one-to-many problem that people used to try to satisfy that. They would create codes that meant something because computing was expensive, memory was expensive, and storage was expensive. What we did for the Securities and Exchange Commission was to create a way to have you go into the EDGAR database, the database of public company information, and to call that out and have it become machine readable. For 25 or 30 years, it was a PDF. You could pull it up, but you had to put it into your programs yourself. The ability to standardize that language has been a 15-year project. It's taken a whole group of wonderful volunteers and a few paid staff to try to create a standardization to language that lets you interact with the SEC's file on a machine-to-machine basis and not have nothing but garbage come out, to actually have useful information come out. Now, why am I talking to you about this at a hackathon? Because I believe that one of the next great movements in computing is going to be the ability to move data between applications like the ones you're building. And that will take a change in the way data is transmitted. It will be transmitted for the value it is, but it will carry with it the definition of what it is, so that you don't have to know, for example, in a comma delimited format, what is in each field. The field will bring with it the information of what it is, and might even bring an audit trail of where it started. I know this sounds a little bit geeky, but think of the savings that would happen if people could pick up information and know what it was. When they brought the information in, the information explained what it was, where it came from. We did this for the SEC. There's a group of people, XBRL U.S. is a part of a worldwide effort to use language standardization. The United States is way behind the rest of the world. Every company in England reports, public and private company reports into Company House using XBRL. The Netherlands runs itself this way. Japan uses it, China uses it, India uses it, Singapore uses it. Many other democracies use it, and we are just beginning to get there. Now, there is a lot of momentum to take the SEC project and move it forward, and that is a new law that's been passed in the United States called the Data Act. Well, the Data Act is an effort on the part of Congressman Darrell Issa and Senator Mark Warner to recognize the strength and benefits that are coming from passing information with a description of what it is, with an audit trail, with all the additional data that lets it become powerfully useful, and requiring the federal government to use this format. I don't want to get too technical on this issue, but I want to open your eyes to the fact that you may be able to powerfully multiply the importance of the applications that you're writing by making the data that you're developing useful by other people's applications. Think of that a little bit. The second idea I want to leave with you, coming from some of my conversations earlier, was that I think a lot of the cyber problem is about to be cured. And again, it has to do with the power of chips. The federal government is changing the paradigm on cyber. We have invested literally billions of dollars in protecting networks, and it hadn't worked. We will continue to protect networks, but we're also going to start protecting data. And we're going to do it by taking advantage of the power of new chips to not only do the business that you want to do, to have the accounting done or the word processing done or the calculations done, but to also encrypt and de-encrypt on the fly. And if the magic of the power of Moore's law is that chips are now big enough to do both types of work at once. So I would encourage you, when you think about things, begin to build cybersecurity into what you're doing with the new technology, and not hold on looking for it as a patch on or an add-on later in developing your applications. The third thing I'd like to mention to you is that I think the world is going to change profoundly, and you saw some of it happening in these apps developed today with the Internet of Things. And if you're interested, I've spent a lot of time looking at the patent structure, what's available in the Internet of Things and what's authorized to do what, and we'd be more than happy to expose you to some of that if you want to get into the near-field communication space. So much for these three ideas: the standardization of language and the ability to massively increase the power of your applications by letting the data that you create be shareable. So much for the change that's occurring in cybersecurity, where we're moving from network-centric to data-centric. And so much for the development of near-field communications and the trillions of instrumented devices that are about to burst upon the market. I want to turn to a question I got when I was introducing myself to some of you, and it talked about what have you learned? I take this as, what would I do differently if I were living my life over again, or what have I learned in my 72 years of experience? I think it's the most interesting question, and I would encourage you to find a way to always be working from a model of plenty rather than a model of scarcity. There are so many applications and so many opportunities that you do not have to hoard an opportunity to yourself. And what this does is allows you to work in the win-win quadrant of life. If I had my life to do over again, I would spend a lot more time taking people out to lunch or dinner or breakfast, trying to find win-win relationships where the transaction between myself and you would be one in which I could find something that I'm really good at, something that's low marginal cost to me and high marginal value to you. I will do those kinds of transactions all day. It costs me almost nothing to share my expertise with you, and it can be extraordinarily valuable to you. And I would encourage you to think about that particular approach to life, because you will find that it returns benefits over and over and over again. I've been profoundly lucky in life. I commented to one of you that a young woman had come up to me 15 or 20 years ago and said, how can I plan my career? And I said to her, do a good job and you might have a career. And I think that's the best advice I ever got, was do a good job with the job you've got at hand, and always try to find that win-win quadrant for dealing with the other people that you're working with. It sounds hard. It sounds like it's a net cost to you, but it's really not over time. And I think you'll find the fact that people never forget. I grew up in North Carolina and spent most of the summers in the mountains of North Carolina. And I remember my father commenting to me one time, said, when you're dealing with people, think of them as if you're hunting a bear. Now, that's a little bit of an odd way to think about things, isn't it? But he was making a very specific point. And his point was, if you can't kill them, don't wound them. That's the other side. Think about it. It's the other side of the win-win quadrant issue. Don't hurt anybody. They will never forget. Don't bruise them. Don't do anything but help them. They will never forget that either. I'm pleased to go in multiple directions in this conversation if you'd like, and if you have questions, I'd be glad to take them. Anybody got any questions? Not a question. I put you to sleep? Yes, sir. I couldn't hear you. Oh, the question is, what's the most important problem that I've worked on? Well, I've been very lucky to work at many different levels. As was mentioned, I had the honor of being a member and then vice chairman and then acting chair for President Bush and President Obama of the President's Infrastructure Advisory Council. And that got at, it started as a cyber-only project. It was Richard Clarke's effort to wake the Clinton administration up to the cyber problem. And it turned out that a lot of the issues that we were dealing with had to do with two kinds of problems. One was information sharing between the public sector and the private sector, and the other was information sharing within this enormous federal government that we have. This is a policy advisory board for the president. It's not designed to delve into operations, but it gets at these human problems of incentives. And you will find as you get out into the business world or the working for government or working for nonprofits, that you will find yourself returning to the problem of incentives over and over and over again. You will wonder why something that seems clear and simple is so extraordinarily hard to implement. And you will wonder why. I talked to a group of cyber companies about a year ago, and they were befuddled by the fact that they had software that could solve pieces of the cyber problem, and they couldn't get anybody to buy it. And the reason is people are just overwhelmed by information. We used to be, when I was in school, you could go to the library and identify every book that had ever been written on a particular subject. Now information is flooding at you much faster than the publishing cycle. So the set of problems that we worked on for the White House on information sharing within the government and between the public sector and the private sector continues to be vexing, continues to be difficult. and really takes a constant effort. I'll give you an example. I actually worked on this yesterday. We are looking for ways to get a particular message out about some cyber issues. And the question is, should we go retail? In other words, can we have conversations with individuals or in small groups? Or is there some way to go wholesale? And the suggestion that I made to a assistant director was that we go to trade associations and talk to the CEOs of the companies in a particular industry, because they have the leverage they have the capability to leverage their voice within their company. So you can have a relatively small number of people, CEOs of electric utility companies. You can have a one-on-one conversation, an intimate, interactive conversation, rather than a canned presentation. And yet, they can go back and amplify that voice. So the toughest problems have to do, it's a long answer to a short question, but it's really vexing. And it gets issues in life like selling your product. These applications that we saw today may well deserve to live in the competitive world. They may thrive, but it won't just happen. It takes a lot of energy to change people's behavior and bring them to a new way of doing things and thinking. So struggling with human motives, human incentives, human emotions keeps coming back to be the heart of the kind of issues that are the most interesting and the most difficult. Other questions? Yes, sir. So the question is, how do I envision technology changing global society over the next decades? Will there be more strife, or will there be a higher standard of living, more peace, a better world as a result of technology? And I think that while we always have a relatively small number of thugs to deal with, whether they are in the drug trade or whether they're in the political world, the net bottom line of technology is extraordinary, and the proof is in the pudding. We are all subject to living 20 or 30 years longer than people who died before World War II. We are living a longer lifespan. Now, this brings with it an extraordinary problem. We have nothing in our structures of modern society with specialization of labor and the destruction of the family unit as the unit of production, the shift of the family unit as a unit of production to individuals working in companies to create goods and services. We have nothing to account for this longer lifespan. And the way it manifests itself in the next great problem in the Western democracies, in my opinion, is the retirement crisis. We are pushing, in the United States alone, we are pushing millions of people out of the workforce just because they got to be 65 or 70 years old. And they're going to live into their late 80s, their 90s, and you all are going to live into your high 90s and over 100 because of the extraordinary changes in the technology of biochemistry and medicine, and in the ability to deliver that information through electronics and computing. So we haven't figured out how to deal with the retirement problem yet. We are creating an enormous population of older people, and we've not yet figured out how to give them either a piece of the current production or to help them save from their current production for their savings and their dis-savings while they're not working. very complicated problem, going to be massively important. You're just beginning to see some of that to be recognized. Does that answer your question? Yes, sir. I have spent too much time with jet engines in the United States Air Force. It's not your voice, it's my ears. The question is, how does governing and government change as technology allows this enormous change in span of control and scope of communications? I was commenting to one of my children the other day that I remember my parents keeping a Christmas card list that had what I thought was a pretty large number of people in it. I'm guessing it was around 250. And it's just pales compared to what the number of people that I communicate with through Facebook and other methods, just through the electronic communications that we have now. So you're on to one of the most interesting questions that I think exists, and there are a lot of people struggling with it. The traditional nation-state approach is probably what we're going to have with us for the next 50 years or so. We haven't had tug between the United Nations kind of governance of the world and individual sovereignty is a tough problem. My guess is that you're going to see a less formal, more politically attuned, more news-oriented layer of human communications occur, and we're going to learn how to filter out the modern term of fake news, and we're going to learn how to deal with shrill voices. I think you're going to see a lot of identity management, a lot of advances in identity management. Who are you in this anonymous, hard to trace world? I think you're going to see significant moves to whitelisting who you communicate with. Blacklisting doesn't work. So just a new URL is pushed up and you don't know who's sending you something. We're going to see a lot more whitelisting of I'd like to talk to you, I'd like to talk to you, I really don't want to talk to you, da-da-da-da. I think you're going to find to do that work and that whitelisting will become a theme of the way we partition ourselves into tribes. There will be many tribes that each of us belong to for different aspects of our interest, and those will be whitelisted for the hardcore communications, and then there'll be a sort of a search function, inform me about new stuff layer, and then there'll be whatever the result is of the crisis that's going on in print publishing now. One of the most interesting issues, one of my daughters is a employee of The Economist magazine. She has a significant P&L at The Economist magazine. And even The Economist, as good as it is struggling with the erosion of print advertising and the movement into targeted digital advertising. How do we pay for the kinds of quality information that magazines like The Economist spend a lot of money developing? When I was at NASDAQ, we spent a lot of time thinking about the value of information and who would pay for what. We owned the real-time quotes, the current price of the stock to buy or sell for 15 minutes. After 15 minutes, it went into the public domain. Well, the people that it was useful to in a 15-minute window were speculators. Investors really didn't necessarily care about a 15-minute immediacy. They wanted to know the general level of the value of the company, but the speculative community lived and died on those real-time quotes in a 15-minute window. we actually developed a grid that talked about everything from real-time quotes and medical information as high value and high priced, all the way to astrology and other kinds of information dispersal that were not important to life or death, but were fun and entertaining and interesting. And there were anomalies in that curve because people would pay more for entertainment than they would pay for certain types of information that really pertain to life or death. So I think that we're going to see the maturing, Carnegie Mellon, there's some Carnegie Mellon folks here, I think. Yeah, there they are. Carnegie Mellon developed a wonderful model that's used in computer science for, it's called Carnegie Mellon's maturity model. How mature is an organization in terms of using computing, and that concept has shifted to many other areas. And I think as we get a more mature approach to using information in the internet, and sorting out these fake news issues and the role of thugs and the role of fake people and the whole ability to identify who's sending information to whom, we will learn how to do that. And it's part of dealing with the avalanche of information that's coming at us now. I don't know if that answered your question or not, but I think it's a struggle. Humanity and humankind is trying to figure this out. We've never had zero marginal cost of communicating around the world. I drove up from Baltimore today. I was on the phone for an hour and a half to Switzerland this morning on Skype. And there were 3 of us on the call from different places in the world. Just stunning to have effectively zero marginal cost to communicate, and we're still learning how to use it. Another piece of this governance puzzle may be that we have different levels of government for different kinds of things that we're dealing with in life, so that you'll get nuclear kinds of issues, chemical, biological kinds of issues dealt with in a totally different way. Then you get less threatening and less disastrous types of problems. But it's a struggle, and what you really need, it seems to me there are 2 things you really need to be able to attract good people into government. And believe it or not, it's actually quite hard to do. And the reason it's quite hard to do is we've gotten very thorough in our analysis and the publication of that analysis about people's faults. Everybody has faults, and we've made it so difficult to serve in government. If you have a fault, or someone decides to point out a fault, or the media decides to destroy a person, we need to figure that out. It's just not right the way it is now. My wife's uncle used to be the chairman of the ethics committee for the American Bar Association, and used to lament at dinner how difficult it was to get good people to serve, even 20 or 30 years ago when he was active. I'm getting the hook. Thank you very much for having me.
Thank you so much for that, Mr. Berkeley. All right, now the moment that a lot of you have probably been waiting for. We will be announcing sponsor prizes. First up, we have the team with the best use of the Giphy API, with each team winning $100 Amazon gift cards and Amazon Echo Dots. Honorable mention goes to Meme Scream, and the winner is Giphy Face Swap.
All right, and if you guys could hold all applause till the end, or at least till the section divides, so we can get through it a little faster. We know you're all excited. The 3 teams winning with the most unique hacks presented by the 1517 Fund, winning $1,000 grants each, are Blink, Explore New Worlds VR Gimbal, and Wokek.
The team with the best use of Lutron's API that wins Lutron Caseta wireless smart lighting plug-in lamp kits HomeKit enabled is Rise with the Sun.
The team with the best use of WebGL graphics, presented by CBRE, winning $100 Amazon gift cards each, is Traveler.
Best use of Vonage and Nexmo API goes to the team winning Amazon Echoes and Vonage gift cards is Liff.
The team with the best use of Google Cloud Computing / Big Data products that wins a Google Home and Google Developer Packs, including $2,500 in GCP credits, is Ascriber. Please come to Town 108 after the closing ceremony, Ascriber.
Team with the best use of the Aladdin API presented by BlackRock that wins drones is Genie.
The team with the best data visualization presented by Goldman Sachs, winning Apple TVs, is Grep Job, with the second place going to ML4 Dummies, winning Raspberry Pis.
And the team with the best Hasura app that wins $1,000 in Hasura hosting credits and a $500 Amazon gift voucher and swag is FridgeSight.
The team with the best financial tech hack presented by Capital One, winning $400 Amazon gift cards each, is Botman Sachs.
The best use of Lyft API with the team taking home Apple EarPods and Lyft swag is Where with Lyft.
The team winning the best use of Expo.io, winning Nintendo Switches, is Caro.
And last but not the least, the team with Rough Ventures, most likely to be a founder, taking home $250 in Amazon Web Services credit is Sidestone.
Good job, guys.
Let's hear it for them.
Now for some of the side event prizes. Winning the 5K, which comes with AirPods, is first place for men's, Sameh Shimdazani. Sorry about that. First place for women's, Sarah Forcier.
The winner of the ping pong tournament, taking home AirPods as well, is Andrew Gu.
And then the winner of the Smash tournament, taking home AirPods as well, is for Melee singles, Jonathan Crespi, and for Wii U singles, Vincent Mack.
Well, let's hear it for them. Now we'd like to call up MLH to make an announcement about their prize winners.
Hey everyone, how's it going? Awesome. It was our pleasure to be here at PennApps. It was an amazing event. First off, before I announce my prizes, can we all give a round of applause to the organizers who worked really hard? All right, and without further ado, I want to say the Amazon Web Services winner was Aperture. They had a photo sharing app, which is location-based and social, so let's give it up for them. And our punniest domain, presented by domain.com, was Sherlock Holmes. So, yeah, Sherlock Holmes is like, kind of like ADT, you know, home security, so Sherlock Holmes. All right, I thought it was pretty good. Great job, everyone.
All right, thank you guys very much. Now for more prizes. From the PennApps side, we have our routes prizes now. So from the real world health and social civic hacking, we have winning, a Nintendo 3DS XL as well as AirPods is Blink. This description again is for the hacks that have had applications in wellness and medicine, and it's sponsored by Penn Sun and the Penn Center for Healthcare Innovation.
The best education hack for hacks that have application in education, sponsored by Palantir. The team is Enigma, taking home portable chargers and gift cards.
For our hardware route, we have the best hardware hack at PennApps going to InventTech, taking home a hardware hacking kit with a value of $500.
For the VR, AR cybersecurity route, with the team taking home Samsung Gear Real 360-degree 4K VR cameras, the 2017 edition, we have Dapmo.
And there's an honorable mention for Where with Lyft. For the best Android things hacked, we have the first place prize of a Google Home, a Pixel XL phone, an NXP development board with peripheral hardware parts for Android things, an ongoing mentorship for the team. Going to, in third place, we have Study Spot. Second place, IntelliFridge. And first place, we have Shelf.
And finally, for the best Google Cloud Machine Learning API hack, the team winning Google Homes and Google Developer Packs, including $2,500 in GCP credits, is Caro.
And as a new thing, we have some hacker shout-outs going to Brain Booster, MyCom, GitHub, and Genie for just having generally fun stuff that people liked. Now we have a video, I believe. Do we not have a video? We'll see in a sec.
All right, it seems like we have a technical issue. We do not have a video. So, that's the top. Let's do that.
Yeah, sure. So before we get our judges out here to announce the 3 winners, we're going to go through a quick rundown of the prizes.
The winner of the 3rd place will take home Apple Watch, portable chargers from Palantir, a swag bag from Hasura, and a medal from MLH.
The winner of 2nd place will take home a GoPro Hero, an Apple Watch, a portable charger from Palantir, 20 cases of Soylent, those lucky guys, so a swag bag from Hasura, and a medal from MLH as well.
And the grand prize winner of the fall 2017 PennApps will be taking home DJI Spark, Apple Watch, GoPro Hero, portable chargers, swag bag, a medal from MLH, and a Lutron plug-in dimmer kit. Right, now, do you want to get the judges up on stage?
All right, do we have the judges here?
All right, let's hear it for
them. Here they come.
Hello. It works.
So what we'll do is first announce a copy of the teams in any order, and then
All right. So we saw some great projects here. We had a really tough time picking the top 3. The top 3 in some random order, in alphabetical order, are. I need to learn my alphabets again. PillAR, Sorry McSorty, and Todd. So we'll. Good job, guys. So in 3rd place, we have some really cool. Who's excited? Robots and augmented reality with Todd.
So we're going to skip to 1st place, so you can figure out who 2nd place is. So 1st place we thought was a great combination of a bunch of different technologies. Computer vision was involved, sensing other things was involved. So your 1st place team is Sorty McSortface.
And 2nd place is PillAR.
Right, before we start heading out, just a few quick logistical notes. If you want a prize, please stick around and come to the front. We'll let you know what the next steps are. The hardware prize winners should head back to the hardware checkout, and that's where they can pick up their prizes. If you board hardware, please return it to the hardware checkout where the bag check is. If you're on a charter bus, you will be leaving from the bus stop on 33rd and Walnut at 5 p.m.
Guys, please don't head out yet. We have a video for you. Our media team worked really hard. And we have T-shirts, extra stuff going to be thrown out at the end, so definitely hang around.
If you also need somewhere to crash tonight, then please stick around and come to the front of the auditorium. To reiterate, anyone who has joined us from Florida and your travel arrangements home have been postponed or canceled due to the hurricane, please text 267-400-0999.
And if you were announced to be the winner of any prize, please go to Town 108 at the end so we can get your information as well as get you your prizes. Please make sure you have all your stuff. Anything left in this building will be cleared out after 5. Yeah, and the lost and found, if any, will be in Razor Lounge in the town building, so make sure to find someone in a blue shirt if you're missing something.
Thank you so much for coming out of PennAppsXVI. We hope you had a great time here. Have a safe trip home, and we hope to see you again in the spring. Let's cue the video.
Celebrate for fake news. Walk out, go, music.
We need more people throwing. We're almost out of t-shirts, so throw slower.
The sound guy said something said it has 4 minutes of rendering left. That was 3 minutes ago. No more negatives. Yes, hopefully they'll be done. I don't know. I'll let you agree to break it. I think it's just a use my comment. Bob is giving out shirts and I don't even get one. Wait, you get, I can grab you some shirts.
If they're gonna play the video.
I know, we gotta get an upshot. Yeah, we were like right up your nose.
How bad are they? I wanted one, but they're all like medium and small. Yeah, they're like yeah.
I don't know if the videos have. Please remember, just a reminder, anyone who won a prizes that the sponsorship team at PennApps has will be at Town 108. So please go there if you have won any prizes that we have announced. Thank you.
Thanks so much for coming, guys. It was a great PennApps.
We're hanging. We're ready.
All right, if it comes on, it comes on.
Wait, you want them here, Sonia? Sonia, you want them here?
If any committee is still here, you can come up on stage for pictures. For PennApps organizers. Yeah.
We have the video, so if anybody wants to announce that.
Yeah, sorry.
That's all right. What's this, yours? You got audio in this video?
Yes.
It's going to come out the headphones.
Over here.
We're going analog today. Raph, we have a video playing.
Okay. So I need to touch anything?
Bring it up. Go.
I'm playing it through Final Cut. Final Cut.
Huh?
Final Cut?
Yeah, hold on. There it is. You want to go full screen there?
Yeah.
participating in PennApps for the first year.
It's really awesome. The food is great. The sponsors are great. Everyone seems really into it.
For hotel industries, we're creating a faster, better way to check in.
I'm working on
can we get some lights on stage for pictures? Lighting, lights on stage for pictures?
Simulations for whatever Unreal Engine is used for, which is like games and military simulations, all sorts of stuff.
pull yours off.
Right. We could do a lot of things, but they're dickheads. Fucking cockpools.